We've talked about the idea of statistics. Now I'm going to give you one example of statistics. And I started this in the last one, and that's the t-test. The t-test compares the difference between two groups. And it's the simplest type of test there is to describe. So I'm going to go into a little detail, and really this will be the foundation of all of the other statistics that I'm talking about. So we want to know, is there a difference between two groups? And let's go back to that example from the last video. Empathy. My pen stopped working for a minute, so I fixed it, back recording. The difference between two groups, we're talking about empathy between leaders and teams, or I mean between leaders and teams. That's my research. Empathy between men and women in leadership. So we have the empathy for women, I'm going to abbreviate it by female, and the empathy for males. Okay, and we have some number there. We measured it maybe on a 5-point scale from the followers, and they've rated their leaders on empathy. And we want to know, do female leaders, as many people propose, do they really have more empathy? By the way, the answer is yes. There is evidence that female leaders have more empathy. And by the way, yes, empathy is a good thing. And by the way, yes, empathy in leaders helps performance, but that's getting into the actual research findings. I'm just using this as an example. And we want to say, do they differ? Well, we can simply do a subtraction. Subtract the two, mean empathy from females from the mean empathy from males, and see the difference. And that means in the top of the test is the difference in the top. Simple as that. And now, is that difference meaningful? Well, we have lots of different measurements of error. And error comes in multiple ways. Did we get the right sample? Do people just generally differ? We call that individual differences. People just generally differ. Not every woman has the same level of empathy. Not every man has the same level of empathy. That doesn't matter. And we also have a third level of error. Remember, I said we measured this on a 5-point scale from followers. Well, the followers fill it out differently. It's an imperfect measurement. And so we have 3 sources of error: sample, individual differences, and measurement error. And we simply have the difference in the top and the error in the bottom. And it's a simple calculation. Once we get to this, and t-test is the simplest because it's truly the mean empathy of female, our rating, minus the mean empathy of male. It's simply that subtraction problem. Now, the measurement of error is harder to do. And in the t-test, the measurement of error, reduce that now and say it is the pooled standard deviation. And I talked about standard deviation a couple of videos ago. So it's the difference in the top and the pooled standard deviation. That is our estimate of error in the bottom. And then we simply do the division problem. And we do that division problem, and then we compare it to the standard. Now, the t-test is normally distributed, the t-distribution. If we did it again and again, it's just a normal distribution, and we're looking for that 95% confidence in the middle and that 5% on the tails. And that's figured out, by the way, for those of you who took years ago calculus like I did and can't do even a tiny bit of it. That's determined by calculus. Like, what are the numbers on the bottom of this distribution? Well, it's determined by calculus. I'm going to just put a question mark there. And so we don't know what those are unless we use calculus to determine the area under the curve and do all that. So we in social sciences look at charts or use computer systems to determine what the typical t-values given this situation would be. And then we do this calculation. And now back to what I did before. I can't remember the exact values I used. 2 of 18 degrees of freedom, we'll talk about this in a minute, equals to, I think I said something like 2.76 or something. And I said P less than 0.05. And then I said there's a Cohen's D equal to some value. I'm not going to do the calculation. I need to actually figure this out. And this is not a course on math. Now, this is our calculated T. We compare that to a chart and we say, oh, that's more than we'd expect by chance. We should bet on that. We're 95% sure or more that there's a difference and that men and women differ in terms of their empathy, that women have different empathy. And then we'd look at the means to say, let's say the mean empathy for females on that 5-point scale is 3.81, and the mean empathy for males is 2.96. We'd say that women have higher empathy than men. Now, the means descriptive statistics are absolutely essential for interpreting the inferential statistics. For example, what if these were switched and this was male and this was female? That would say we're not right, even though it's statistically significant. We're not right because the means are in the opposite direction, but we're going to keep them to this for the example. This example is consistent. These numbers are too extreme, but this is example with the research. So what we're looking at again is this p-value. Does the p-value show that the difference in the top is greater than what we'd expect by error? The difference in the top and our estimate of error in the t is our pooled standard deviation. And it's as simple as that. Is it more than would be expect by chance, and how big is this effect? Now, degrees of freedom. Degrees of freedom have to do with how much varies, how much room we have for variability. So if I said my wife's age is 53 and our mean age is 55, I could ask you the question, what's my age? And you could figure it out. And you could quickly tell everybody that my age is 50. My wife, by the way, gave me a dirty look when I gave you her age. So you could figure out that my age is 55. It's pretty quick. My age, once I've calculated that mean, my age is no longer free to vary. We're working with variables, but once we calculate a mean, one of those values is no longer free to vary. So this degree of freedom, I picked it, and it says 18 degrees of freedom. Well, we've calculated one mean for females, one mean for males, so we've lost 2 degrees of freedom. And that means we have 20 people on our sample, 18 plus 2, 18 things free to vary, 2 things that we've lost that freedom to vary. We have 10 men and 10 women in our sample. That's what that degrees of freedom mean. So t-test, it is the foundation for all of that. So for the t, it's the difference in the top. Simple, truly, is just a subtraction problem. And the pooled standard deviation in the bottom. So in the top, it's what we want to know. This is, I'm generalizing now, to in the bottom, what we don't know. Error. And all inferential statistics boil down to this. What we know, the difference in the top, the difference between men and women, and what we don't know in the bottom, what is our error, our estimate of error. So we have an estimate in the numerator, an estimate in the denominator. We simply do a division problem. Now, all inferential statistics all do this same thing as the t-test, and they compare it to a standard figured out by calculus, the guesswork based on this sample size, how big would we expect this to be by chance? And they do it with this simple calculation. So this is the theory of statistics right here. The next one I'm going to do is ANOVA. And you'll see ANOVA is very similar to t-test. It just one step beyond this.